You might have noticed that your electric company charges you for something called kilowatt hour, or kWh. Well, what is a kWh, and how is it different than just a plain old kW, or kilowatt? Well, the simplest way to put it is that kilowatts are a unit of power, while kilowatt hours are a unit of energy. Now you might be thinking, well, wait a minute, aren't power and energy pretty much the same thing? Well, not exactly. When we're talking casually, we often refer to power and energy pretty interchangeably, but they're actually quite different terms and they mean different things. Let's look at power first. Most appliances have a power rating. For example, let's say we have a light bulb with a power rating of 100 watts. Here's our light bulb, 100 watts. Power rating is like the amount of electrical strength that it takes for something to work. Think of a weightlifter who can lift up to 100 pounds. The 100-pound weight in this case is a bit like the power rating of the light bulb. It's the amount of power that's required at any given moment to do the work. A stronger weightlifter might be able to lift a higher amount of weight, like 200 pounds, and also lift the 100-pound weight. Likewise, a larger power source might be able to also power a 200-watt light bulb in addition to the 100-watt light bulb. Energy, on the other hand, is what's needed to keep the power going for a certain amount of time. For example, how much energy would it take for the weightlifter to lift the 100-pound weight for a full minute? We'll say that the energy he needs is equal to 100 pounds times 1 minute. And that's equal to 100 pound minutes. Now likewise, if we want to power the 100-watt light bulb for a certain amount of time, we need a certain amount of energy. Let's say we want to power our 100-watt light bulb for a full hour. In order to do this, we would need 100 watt hours of energy. Now let's suppose that we want our weightlifter to lift the same weight for twice as long. For the sake of argument, we'll say he doesn't get tired after the first minute. Well, in order to do this, he would need twice as much energy. He would need 100 pounds times 2 minutes. That's going to be 200 pound minutes. By the same token, let's say we wanted to power our light bulb for twice as long. We'd take 100 watts times 2 hours. We get 200 watt hours of energy required. We can also look at a difference in the amount of power required. For example, let's say that the weightlifter now instead wants to lift a weight that's 200 pounds for a full minute. Take 200 pounds times 1 minute, and we need 200 pound minutes of energy. Same thing with the light bulb. Let's say we wanted a 200 watt light bulb to be powered for 1 hour. We would need 200 watt hours of energy to do that. So far, we've only been talking about watts and watt hours. Well, what about kilowatts and kilowatt hours? Well, kilo in this case is simply an abbreviation for a number. In this case, 1,000. So, if we have 1 kilowatt, that's going to be equal to 1,000 watts. Similarly, 1 kilowatt hour is 1,000 watt hours. Sometimes you'll also hear about a megawatt. 1 megawatt, or MW, is equal to 1,000 kilowatts, or 1,000,000 watts. And a megawatt hour is equal to 1,000,000 watt hours. This is just a simple way to not have to write all of these zeros. You can just use the abbreviations K and M. I want to pause here for a moment to talk about this hour component of the kilowatt hour unit, because I think this is one of the most confusing and counterintuitive aspects of discussing energy. When we talk about energy, we often use units like the watt hour or the kilowatt hour. And as we learned, a watt hour is equal to 1 watt times 1 hour of usage. Now, when people hear something like watt hour or kilowatt hour, often they automatically think that a watt hour is equal to 1 watt per hour, where the watt is divided by the hour. Now, this is completely understandable because this is exactly how we're used to thinking of something like a speedometer, where we have units like miles per hour. But watts per hour is really a totally meaningless unit. It doesn't really exist because the watts is already in per hour unit. The watts is already a per hour unit, and dividing by hours again doesn't really say anything. By measuring energy in watt hours or kilowatt hours, it's really more like looking at your odometer, not your speedometer. Watt hours tells you how far you've gone or how much energy you've consumed, not how fast you're going. Power, on the other hand, is what tells you how fast you're going or how much energy you're using at that exact moment. So to complete the analogy, watt hours is sort of like your miles that you've traveled, and watts or kilowatts is sort of like your miles per hour or the speed that you're going. If you're still confused, another way to think about energy is to think of a battery. Think about a battery in something like a cell phone or a laptop computer. Most of these devices have some sort of a battery life meter that might look something like this. This is sort of like an indication of how many watt hours or kilowatt hours you have left in your device before the battery is empty. You can think of the battery a bit like a bank account, where kilowatt hours is the currency being stored. Once your battery is depleted, you don't have any more kilowatt hours to withdraw from your account. Power, on the other hand, is how fast you're using up that energy over time. The higher the power of an appliance, the faster the energy is used up, and the faster you're taking kilowatt hours out of your battery bank account.